Yeah. All right. Okay. Okay. Yeah. Welcome to this community call for July 2022. The today's agenda will be we have two speakers, Feng Jian and Saga, talking about some practices and new features. Quickly, I will spend some minutes to show you the updates from the community. So yeah, as you say, we are approaching 0.12 release, and we have a wide range of committers and contributors and commits, and we are landing PRs. So things are trending up. There are quite a few major RFCs under development on the community. So you see, you have ByteDance pushing Metastore server, table management service, and we have other companies, Uber, Alibaba, AWS, and also OneHouse. We are pushing new major features as RFC, and most of them, like half of them are under implementation, and some of them close to land. And there are also some ongoing discussion with some of them also on RFC discussion. So yeah, 0.12 is on the way. In this release, we will have some quite some performance improvement and simplifying some usability from the config perspective. We added Spark 3.3 support, and core procedures will support a bunch of new commands. So yeah, this is slightly different from last release, which is the feature reach. This is more of a bridging release that we trying to stabilize and improve the overall performance of the usability. Yeah, that's pretty much about the update. So without further ado, I will pass on to Feng Jian for talking about the practices of Hudi in Shopee.
Okay. Do I need to share my screen?
I'm sharing for you, so you can go ahead.
Okay. Hi everyone. My name is Feng Jian. I work for Shopee as an engineer in the data infrastructure team. Today I will talk about practice of Apache Hudi in Shopee. The current presentation is divided into three parts. The first part will share the background of our choice of Hudi as our data lake component. The second part will share with you why we choose Hudi. Part 3 will share with you how we use Hudi in our production environment. Okay, next. Now let's move on to the first part. I think the evolution of the system is the process of solving the problem. The reason our team started Hudi, it was also because in the process of providing services to the business team, there are some problems that traditional services could not solve. That lead to the introduction of Hudi. Next, please. This architecture diagram shows the end-to-end solution provided by the data infra team for business requirements in Shopee. At first, the bottom part is data integration. We have data integrations based on log data, database, and event stream. Secondly, load data into data warehouse through ETL service in platform. Finally, business team will do data processing through compute service in platform, then use ad hoc engines such as Presto for data exploration or demonstrate result on dashboard. But in the process, we found 3 typical issues. Next, please. The first issue is data movement. Same data in database need to be processed both in batch and real time. In the old solution, there are 2 pipelines, fully snapshot and change data capture to satisfy batch and incremental requirements. But a fully snapshot is not efficient way to export data from database. It's hard to keep data consistency and also need a lot more storage. Next. The second issue is traditional batch data set can be thought of as a snapshot of business data at a point in time, compressed to a point snapshot to process information in a business process. This change reflects the process of user using our services and are very important objects for analyze. But once merged, it cannot be expanded. In many scenarios, the portion of the business data that changes from day to day is only a small fraction of the total data. Storing every batch in fully snapshot is a huge waste. Next. The third issue is joint DW table creation. Near real-time DW table creation is a common scenario in data processing. The problem is that the traditional batch processing, the latency is too high. And if we using streaming computing engines to join multiple streams, it will cause a waste of resources. What we expect to achieve are below objects, such as multiple source, parcel column updates, low latency, and a large wide target table. Okay, next, please.
Okay.
Based on these business problems, we chose to use Hudi to solve this problem. Next. Hudi has good support for streaming scenarios. We want to use a pure streaming approach to build our data integration environment. So streaming support was one of the reasons we chose it. For the compatibility of various big data ecosystems, the data set we build will be loaded with multiple demands, such as batch processing, stream processing, incremental processing. These workloads currently run in variety of computing engines, so support for multiple computing engines is also why we choose it. In line with Shopee's business needs, most of the data set we need to deal with at present come from business system with unique identification information. So the design of Hudi is more in line with our data. Next, please. Flink and Spark are currently available on our platform as general purpose computing engines. As load for data integration and data warehouse construction, use Presto to host data exploration. Hudi supports all three. In practice, the importance of business data varies, and we need to provide user with different way to index data. The third reason is Hudi fit business needs. Schema, for example, schema change for user are very common needs during data integration. Data change in ODS may cause errors in downstream computing tasks. Also, in incremental processing, we need the semantics of time travel to process specific snapshot. Okay, next. Based on the above features of Hudi, we have implemented Hudi in our internal process. Here are 3 examples of real-time data integration, incremental view, and incremental computation to share with you. At present, Shopee has a large amount of internal business data from business database. We use CDC-like technicals to capture change data in the database. Build ODS layer data for business to support batch and real-time incremental processing. When a business party's data needs to be ingested, we will do a full bootstrap to build the base table before incremental real-time integration. It's then built in real-time ingestion based on CDC data. In the data processing, we generally choose copy on write type or merge on read type to build Hudi table according to users' requirements. Okay, next. In our real-time build process, the most common problem are about 2 types. One is that the user can fix the type of table with massive updates in old partition as copy on write table, which leads to write amplification. What we need to do at this point is set up the appropriate monitoring to allow us to identify this issue. At the same time, we support the inline and asynchronous compaction of data file based on the configuration of data merging logic. The second problem is that the default Bloom filter causes false positive problem in last table. In this case, HBase index is used to solve the problem of writing large data set. What's more, we improve HBase index to solve data skew issue in reduced servers. Next, please. This is an effect of replacing some of our data integration pipeline with real-time Hudi-based integration. The left figure shows a relationship between the ratio of data visibility and the time delay. For now, we can guarantee that the data will be visible within 15 minutes. And 80% of the data is visible and usable within 10 minutes. The graph on the right shows the consumption of one resource as a percentage of our resources. The blue part is the resources consumption of the Hudi pipeline. By contrast, the red part is the resource consumption for batch data integration. Because switch to the real-time pipeline, the repeated processing is reduced for the data. It also reduces the resource consumption caused by batch fully snapshot process. As a result, our resource consumption is much lower than batch processing. Okay, next. The second example is snapshot view based on save point. For the scenario where users need state detail, we provide service based on Hudi save point. Build a periodic snapshot based on the time period required by the user. These snapshots are stored as partition in the metadata management system. User can easily use Circle to access this data in Spark or Presto. Because this data store is complete and has no merge detail, so data itself is to support the full amount of data calculation. Also support incremental processing. Okay, next please. In the use of snapshot view, for some scenarios where the proportion of changing data is not large, a better storage saving effect will be achieved. We have a simple formula here to calculate the effect. P represents the proportion of changed data, and the T indicates the number of time periods to be saved. The lower the percentage of changing data, the better the storage savings. So there is also a good savings for long periods of data. At the same time, it has benefit for incremental computing resource saving. Okay, next. Okay, this is the second example, incremental process. When our dataset is built based on Hudi tables, we can support batch, incremental, and near real-time processing loads at the same time. For example, table A is incremental table. When we build our subsequent tables B and table C based on table A, if the calculation logic supports incremental construction, then we only need to obtain new and change data during the calculation process. In this way, the amount of data involved in the calculation is significantly reduced. Okay. Here is an example. It is an offline computing platform based on Hudi incremental computing to build a near real-time user job analysis. When a user submits Spark job to the cluster, the system automatically collects user logs and metrics after the task is complete. The metrics and key logs are extracted and written to the Hudi table. Then a processing task incrementally reads these logs and analyze the optimization items of the task. So when a user job finished running, the user's job status can be analyzed within 1 minute, and the analysis report can be formed and provided to the user. Next slide. The third example is incremental join. How do you implement parcel updates such as a large table that is merged by two smaller tables? In this case, we have a result table have two columns, C1 and C2, and the result table is merged by two small tables. Table 1 only have column 1, and table B only have a C2. Hudi's incoming data is implemented as payload. There can be only parcel columns of table exist in a payload. By leverage the merge API of payload, we implement a new parcel payload. The payload for the incremental data is written to the log file. And the wide table used by the user are then generated in subsequent merge. Okay, next slide, please. This is the advantage of parcel update. The first one is significantly reduce the resource usage of streaming large and wide table construction. The second is file level data modification increase the processing efficiency. This is because Hudi store records by its record key, so we don't need to fully join in this case. Here is what we do for the community when we were doing internal requirements. We are also contributing to the community, like some new features and improvements. For example, write API file log metasync. What's more, we also fix some bugs. Okay, that's everything. Thank you.
Okay, thank you, Feng Jian. That's a good sharing, and I'm glad to see that you're making contributions. Your team and folks from Shopee are making contributions. Cool. Let's move on to the next talk. And Saga,
I just had a quick question on one of the points. What piqued my interest is that snapshot view based on save point. I wanted to know how frequently do you save point, and when you back up that in your metadata store, do you go ahead and remove the save point commit from the Hudi timeline?
It's determined by the user requirement. Usually we create one save point per day, and we will also remove the save point if let's say user want 1 month data. So we will remove the save point before 1 month ago.
I see.
Yeah.
Thanks for answering the question.
Any other question from the audience? Okay, let's move on to the next speaker. Saga, over to you.
Thanks, Raymond. Hey folks, I'm Sagar. I'm a database engineer here at One House, mostly contributing to the Apache Hudi project. I'm a committer in Hudi. And today I'll just give you a state of the union update on our Hudi integration with PrestoDB and Trino. Next slide, please. So Hudi has been the earlier integration that was done with Hudi was way back 4 years ago, and this picture shows how that integration has evolved over those last 4 years. And this marks the version numbers that you see here are for Presto. That's where we have added more and more improvements in the Presto Hive connector. We'll talk about each one of them in a bit. In the Trino Hive connector, some users may be aware that our state of integration is still at the first stage where we support only snapshot queries on copy on write tables and read optimized queries and merge on read tables. And you have to drop the Hudi Presto bundle inside the Trino Hive installation. All these improvements that you see in later Presto versions are still not there in Trino Hive connector. But we have Trino Hudi connector that is very near to landing, and we'll get to that in a minute. Next slide, please. So in Presto, between these versions 0.233 and 2.40, the first integration was based on input format, and well, even before this, right? Up to version 2.33, it was simply based on input format get splits. We had an annotation here, which we would check in the Presto Hive split loader, and then we'll call our custom input format to fetch the splits. In versions greater than 2.33, we actually saw some perf degradation with that approach, and we started using path filter. And we memoized this path filters so that we save some computation. Additionally, we made Hudi a compile time dependency, so users didn't have to place that Hudi Presto bundle in the Hive connector installation. On the performance side, this resulted in way lesser RPC calls to the name node using the path filter approach. Then next, in later versions, next slide, please. Yes. So up to that point, version 2.40, we only supported read optimized queries for merge on read table. Snapshot querying on copy on write was already on par with querying Parquet files with Hive connector. But we wanted to bring the same kind of efficiency to merge on read tables, snapshot queries for merge on read tables. To do that, we implemented a custom split converter interface in Presto Hive connector, which basically understands, which maps a Hive split to Hudi split, which then understands the merge on read tables in Hudi, essentially the merging of the log files with base files to generate the splits. And the beauty of this custom split converter interface is that you can even generate splits for bootstrap tables, as we did in a future version. If you go to the next slide. Yeah, so bootstrap tables, adding support for querying bootstrap tables was added in Presto 268. And it was a very simple implementation once that custom split converter interface was added. So today, just using the Presto Hive connector, you can do snapshot querying for copy on write, merge on read tables. You can do the same for bootstrapped Hudi tables. Um, and yeah, from version 272 later on, we added few more improvements. Next slide, please. Okay, so we realized that this file listing, even though we had memoized path filter, file listing was where query planning spent most of the time. And in order to eliminate any recursive file listing, we added metadata based listing uh, in the Presto Hive connector. In Hudi, we have this metadata table. It's an internal merge on read table. But essentially, it's more akin to indexes in databases. So we have multiple indexes in the metadata table. One such index is files index, which stores a mapping of files to partition paths. There are other indexes as well, such as column stats and Bloom filters. Um, but our first, the first index that we integrated with is files index, which really helped in improving, eliminating any recursive file listing. We make use of the file system view to fetch all the data files. And this file system view itself is just loaded once and cached throughout the session of the query. Next slide, please. So on master, now we added this new connector, which opens up more optimization opportunities for us, which we'll talk in a bit. Next slide. Before we go into the new connector, just want to briefly mention here about Trino Hive. So Trino Hive, as is today, it supports snapshot querying for copy on write table, read optimized querying for merge on read tables, and there are no metadata based optimizations that we have in Presto Hive connector. So that's the current state. Yeah, let's go to the connector now. All right, so before the design, I just want to talk about the motivation behind writing this new connector. And by the way, I must mention that this is a great example of where sub communities of Hudi came together to land this connector. ByteDance engineers worked on Presto Hudi connector, while One House engineers worked on Trino Hudi connector. So why a new connector? At least on the Presto side, one may ask, right? We already had so many things happening through the Hive connector itself. So why write a new connector altogether? So first thing is the adoption of new Hudi features, especially if you have been following past couple of Hudi releases. As I mentioned before, we enabled metadata table by default, and we added multimodal index support, such as column stats for data skipping. And that is also related to the performance improvements that we see. We wanted to bring the same kind of improvements on the read side through several other engines, not just limited to Spark, but also Presto, Trino, or Flink. So those were two main motivations. And another third one was, um, as we started adding more and more improvements to the Hive connector, we realized that in order to adopt with these latest features in Hudi, we'll have to make changes in the hot path of the Hive connector, the core reading path of the Hive connector. Uh, Presto community had some concerns there. So together with them, we came up with this. We came up to this point that now it's time that we build a new connector for Hudi. Well, we'll continue to support the Presto Hive connector or Trino Hive connector, but all major integrations with these new features will be done in the Hudi connector. Next slide, please. Yeah, so one point about stability, and this is where I feel uh, uh, we as a community should do more, should make more noise in Presto and Trino. If you look at any modern lake storage formats such as Hudi, Delta, or Iceberg, their connectors, they all need to interact with Hive Metastore. They all heavily extend bits and pieces from Presto Hive connector. So I think the Presto Hive community should carve out some clear interface for integrations with these storage formats, not just Presto Hive, Trino Hive as well. And they're already towards that path. Such as they built extended Hive Metastore, which other connectors such as Hudi or Delta can talk to. But we lose certain benefits with the new connector. We lose certain benefits of the Hive connector, such as recently Alexio enabled caching for Hive connector, and then there is an ongoing project in by Meta as well called RaptorX, which again improves your query. These are all on the query planning, improves the query planning. So in order to reap those benefits in these connectors, Hudi, Delta, or Iceberg, I think it makes sense that the community carves out clear interface for integration with these storage formats. But that's something, a discussion for another day. But would love support from the community. Go ahead and maybe raise some issue there. We already have something there. I can add a link later on in this slide. Let's move on to the next slide.
Sagar.
Yeah.
Yeah. I mean, sorry to interrupt. So just had a question here. So this third point, does this mean at a later point of time we can revert back to developing in the Presto Hive connector itself and leave the Presto Hudi connector in whatever form it will be at that point of time? Does it mean that, or like?
I don't think so. Well, I don't know, but I don't see it that way. That's my take, because the community wouldn't still want to, disturb the have these conditionals in the core Hive reading path. So yeah, I guess at this point I don't have a very good answer for that. But if I project into future, I don't see that happening. Going back to the Hive connector.
Okay. Okay. Yeah. Thank you.
All right. Yeah. Let's go to the next slide. So this is the design of Presto Hudi connector, and Trino Hudi connector is more or less similar. As I mentioned before, that there is an extended Hive meta store through which the Hudi metadata interacts with the Hive meta store to get all the metadata. Once you do the meta sync for a Hudi table, its metadata is saved in HMS, right? So Hudi metadata class here leverages that. The to two other things, unique things, which is different from the Hive connector, is that first, we are reusing any optimizations that Presto has already done uh, for reading the pages itself. So for example, for copy on write tables, those are basically Parquet files, right? So we did not write any new page source. We just reuse the existing Parquet page source. Um, uh, Going ahead, even in future, to support comprehensive schema evolution, we may extend from this and make some changes there, given the way Hudi stores schema internally. But it still won't change the reading of this Parquet page source part. Um, and For merge on read tables, we added this log file reader, which essentially merges your log files with the base files, the log blocks with the base file, um, to read the full page. Um, and then the meta client, we do use meta client in Hive connector as well, Hudi table meta client. This is useful as it gives you the complete timeline view of the table, right? So together with the metadata and the timeline, you get a complete transactional view of the Hudi table. For the upcoming features, such as support for incremental querying, the, currently we don't support, we don't have incremental queries support in Hudi or Trino connectors, uh, uh, Presto or Trino connectors, either Hive or the new ones. But we are in the process. It's a work in progress where we'll be adding incremental query support. To read more about the design of the connector itself, I, I have the RFC docs mentioned here in the slides. You can head over to that. Yeah, next slide, please. I think a new Hudi features, I've already mentioned these. So metadata table, um, it's just a session property through which you can enable metadata based file listing. Then you can already see the benefits of clustering. If your Hudi table is clustered, you can go ahead and read that using Presto or Trino connectors. Querying change streams and data skipping integration. Those are two things which are in progress. Querying change streams is nothing but the incremental query support. As I mentioned before, the timeline through the meta client will help us do that. The other is data skipping. We plan to put out an RFC with respect to this. Um, Again, the design principle here will be to reuse as much as possible what Presto itself or Trino itself provides for data skipping. But those need to be, we need to integrate with the column stats index of the metadata table, right? Um, there is an RFC, a draft RFC. I think Pratyaksh here, he's in the call. He's already working on that. Next slide, please. Yeah, for any early integration, if you're interested about what were the challenges that we came across for while integrating with Hive connector itself, then there's a very nice blog on PrestoDB site itself where you can read more details. For the connector itself, on usage, in Presto, we already have the docs out, so that has landed. Trino, the usage is similar to Presto. One still needs to Hive sync the Hudi table, and then just change the name of, so some changes in connector properties, which is there in the doc. And the design, these are the two RFCs for Presto and Trino. And any ongoing work, if you want to keep track of or want to contribute to any ongoing work, head over to these two Epic Jiras, and these contain all tasks that are in progress or still open. Feel free to pick up any of the tasks there. Next slide, please. In the roadmap, as I mentioned, these three are ongoing work, and Trino Hudi connector is very near to landing. Going forward, we'll have full integration with different indexes in metadata table. We'll have comprehensive schema evolution support. And then there are some changes which do not affect it directly, but these are some abstraction level changes, some change in the abstractions in the file group reader. And by the time we release Hudi, by the way, below are Hudi versions. So by the time we release Hudi 1.0, which we hope for towards the end of this year, we want to add complete DDL, DML support in these new Hudi connectors to support time travel updates and deletes. Yeah, so that's in our future roadmap. I think that's all. I'm open to, the floor is open for any questions.
Yeah, thank you, Saga. It's a nice walkthrough of the evolution of Presto support.
Yeah, thanks.
Any question from the audience? Okay, I guess there's no more questions here. We can end this community thing now. Thank you guys for attending.
I guess I may have a question, maybe for the Shopee speaker.
Okay.
If he's still here. Like with regards to the partial update implementation for merchant read, if you could just sort of briefly summarize how that works. Like, do you essentially need to merge any log files for incremental and then merge into the table? Is he still here?
From there, are you there?
Okay. What's the question? Sorry.
I don't know if you could. Yeah, I guess if you could briefly summarize, yeah, like this implementation for partial updates on merge on read tables.
Basically, we implement a partial update payload. It can support partial update on merge on read table. Yeah, we also solve some problem if because if there are multiple source, there usually we have out of order events in a streaming application, so we need multiple ordering field. We also solve that problem.
I see. So then, you can provide essentially multiple ordering fields, or you basically just rename from each one of the sources into just some other new column into your table, and then solve it that way. Do we use just a single precombine?
For now, it's just a new column. Like if we have two tables, we have two ordering fields in the result table, and we will store the ordering field and the mapping of ordering field and the column store it into the precombine field in table config. So so we can get the mapping releasing when we do Perkin-Ban or compaction.
Makes sense. Yep. Do you see any problem? Like, is it supported for both? I guess, like, I don't know, like global and non-global indexes. Do you have those use cases, like for global index? In particular, like cases where maybe like the partition column may need to be updated.
You mean cross-partition update, right?
Essentially, yeah.
Yeah, we have user have similar requirement. They want cross partition update, but we don't support it for now.
Okay. Yep. Fair enough. Yeah.
Okay.
So just to follow up on that, if you use global index, and there's an option also to turn on to actually move the records from one partition to another during update. I suppose that would be that can be adopted in your implementation.
Okay. Yeah. So we were actually trying that, but I mean, on copy and write tables and using like the override non-defaults. We were actually running into some issue. We like raised it, I guess, on the issues. But yeah, I guess my follow-up question is like, so what's the future, I guess, for like partial updates, like in the next release, 0.12? I'm not sure if I may have missed this. Is it supported, like officially supported? I know it's not in 0.11.
No, not yet.
Okay,
Yeah,
so it won't be supported in 0.12.
No, 0.12 won't have this feature, but this is on one of the major RFC where we are gonna land, and for 0.13 that we will have new set of merge API, and then it will allow implementation of such like a partial update. So yeah, I mean, even today, if you want, I think you can still implement the partial update payload and make it work.
Sounds good. And then, so then the next release, is there like a timeline? I think on the slide it just said like coming soon. I'm not sure if I may have missed it.
Yeah. Point 12 is targeting at early August.
Okay, sounds good. Thank you.
All right. Any more questions from the audience? All right. I think we are right on time. Thank you, guys. See you next month.
Thank you.
Thank you. See you.
Thank you.
Thank you.
Thank you. See you.